So this is a video on section 7.1, solving right triangles. In chapter 6, we reviewed how to find the sides of a triangle, but in 7.1, we introduced trying to solve for angles. If I draw a triangle like this, we're going to label it like we normally do. So this is C, B, A, and little a, little b, little c. And this is usually 90 degrees with these problems. Unless they say different, but usually it's 90. If they ask us to find for angle A, so this is angle A right here, we have to label what the opposite and adjacent is. And if they ask us for angle B, we have to swap it. I'm going to do for angle A, I'm going to do it in blue to show. So the opposite of angle A is actually little a. So the opposite for A is little a. But the adjacent for A is B. But what about for angle B? Angle B, the opposite is going to be little b, and the adjacent is going to be little a. So if they ask you to solve for angle A or B, you have to adjust it depending on what the opposite or adjacent is for that angle specifically. And then another thing that's important is in this chapter we talked about two things. We talked about the angle of elevation and the angle of depression. So if we talk about the angle of elevation, what it looks like is, picture, if we have in our book, we have an eye, right? And the eye is going to be looking upwards. So the angle is going to be going like this. But if we're talking about, so this is elevation. But if we're talking about the angle of depression, it's going to be looking downwards. Like this. So depending on the problem that you're given, you have to solve for either way. So we're going to first work on solving for the angles of a triangle, and then we'll work on doing problems more similar to solving for the elevation or for depression. And 7.1 has only these problems. But all of these problems are very often used on the exam. So let's do the triangle one. Let's draw it out. So problem one says that C equals 90 degrees and angle A equals 55 degrees, where little a equals 30.0 meters, and they're asking us to find angle B. We don't know what that is. B and C. Okay, so let's label a triangle with all these parts. I'm just going to copy this up here. So that's 90, A is 55 degrees, and we don't know what B is. We know what A is, which is 30 meters, and we don't know what B and we don't know what C is. Okay, so how can I approach this? If I want to find angle B, actually that would probably be the easiest thing to start with because I have two of my angles already. So if you have two angles, you can actually just solve for that right away, the angle B. So I'm going to first start with my B. And how we do that is a triangle, all three angles will equal 180. So it'll be 180 minus 90 minus 55.0, which is just 55. So in my calculator, let's see what this is. 180 minus 90 minus 55.0. I get 35 degrees. So I know that angle B is now 35 degrees. So this can change. Now we're going to put this guy in there, since I already have it. So we know angle B is 35. Then I want to find side C and B. Well, since I found angle B already, I can use that, or I could use angle A. Let's try angle A. Let's use A in this example, since the opposite of that I have already. I have this guy right here. So if I am looking, let's say I want to look for solving for C, I'm going to start with the hypotenuse. So if I look at that, I know I'm going to use SOHCAHTOA. But which one do I use? So this is opposite, and this is the hypotenuse, and this is my adjacent for A. That means I need to use, probably, if this is opposite, I'm looking for hypotenuse, I'm going to use sine. Sine of A equals to opposite over hypotenuse. So that would be little a over c, which then would be 30 over c. Well, I need to find c, and I know what the sine of a is, so let's reset this up. So sine of a is 55.0, 30.0 meters, and c. So what I can do is I can actually switch these two to find c, which means it's going to be 30.0 meters divided by 55.0, or sine of 55.0. I have to make sure to hit the sine. So in my calculator, let's see what that comes out to. So 30.0 divided by the sine of 55.0. And I get 36.62 for the side. So that is our C. Now, so we know this is C. Now we can do the Pythagorean theorem to then solve for the last side. So a squared plus b squared equals c squared. We know my a is 30. I'm just going to leave it as 30. I don't know what my b is, so I'm trying to find that. And then I know what my c is. So 30 squared is 900. And then 36.62 squared is going to be 1,341. I'm just going to put the full number. And then if I want to get b squared by itself, what I do is I subtract the 900 from the other side, or to the other side. So b squared equals, so if I subtract 900, I get 441.0244. Then we take the square root of both sides. And I know you guys know this by heart at this point. So I get b equals 21 meters. So we found all of our sides. So this is how you'll solve every single time, but I want to show another example where it might be a little bit different and you might not have all the angles, you might just have the sides. So this is how you would solve one way. Let's do another example, and I'm going to see if you guys can do this on your own. I'm just going to set it up, and then you guys can solve and pause the video. Okay, so welcome back. I want you to try this problem, and pause the video, and then try it on your own, see if you can get the answer, and then we'll go over it together. For this problem, they give us the two sides, but we're missing one and we have to find the angles. So to find the two sides, we always use the Pythagorean theorem. So we will do a squared plus b squared equals c squared, where a is 8.3, b is 11.2, and c is what we're trying to find. So 8.3 squared is 68.89, and 11.2 squared is 125.44. Now we just add them together. I get 194.33. And then we take the square root of both sides. And we get 13.9 meters. So we know C equals 13.9. Now I want to find angle A and angle B. I have one angle, I have 90. So if we find one of them, we can find the other one by subtracting by 180. So I'm going to choose to do angle A first. So angle A, the opposite of angle A is little a, and the adjacent of that is little b. Or we could do the opposite over hypotenuse. Let's try that one. So sine of the opposite of our hypotenuse. The opposite is little a, so little a is 8.3. And h is what we just found, 13.9. So I'm going to do sine to the minus 1 of 8.3 over 13.9. So let's see what that is. Sine to the minus 1 of 8.3 divided by 13.9. So I get 36.6 or 7. The decimal will be off depending on how you calculate it, but let's just do 36.6. And then I can find, so we just found angle A, so this is A. And then if I go to find angle B, I just subtract. So 180 minus 90 minus 36.6, and I get I get 53.4 degrees. Now let's say you decided to do angle A a little bit different. Let's say you decided to do angle A as opposite over adjacent. So let's do that as an example. So opposite over adjacent is tangent, which is A over little b, which would be 8.3 over 11.2. So tangent to the minus 1 of 8.3 divided by 13.9 is 36.4. So if you notice, the decimal is going to be off a little bit, but it's always going to be the same angle. So we could just round this off as 36 degrees. Both of them would be 36 degrees, but they're still in the same range. And let's find that angle again. 180 minus 90 minus 36.4. We still get a similar answer. As long as it's the same degrees, the point will not really matter as much, but either way will work. So that's how we solve a problem like this one. Now let's do a problem where we have to solve for elevation or depression. So let me write that out. So let's do this example. If a 60-foot tall tree casts a shadow of 45 feet, what is the angle of elevation of the sun? So if we talk about elevation, the angle is going to be like this. Here's the tree, and we're looking for this angle. So they say that the tree is 60 feet tall. This means this is here. And then if it casts a shadow of 45 feet, it means this is here. And let me label my sides. This is A, this is C, this is B. This is little a, little b, c. So we treat this as the same problem as the last one. So if they're asking us to find angle A or the elevation, what we have to do is we have to use the sides they give us. So they give us the opposite and they give us the adjacent. So if I look at SOHCAHTOA, this would be tangent because opposite over adjacent is what we're looking at. So my opposite is 60 feet and my adjacent is 45. So that means I'm going to take the tangent to the minus 1 of 60 over 45. And I get 53.1 degrees. If you just put it as 53, that's okay too. But then let's do an example of depression instead. Okay, let's try this example. You are standing on the top of a lighthouse overlooking the ocean. The angle of depression from the top of the lighthouse to the boat in the water is 42.5 degrees. If the lighthouse is 50 meters tall, how far is the boat from the base of the lighthouse? So we'll draw this out. Let's draw our lighthouse here. And they say that there's a boat in the water, so our boat's going to be here. And we're doing an angle of depression, so that means we're going to be going downwards like this. But picture the angles here above. So it's a little bit different. And they say that the lighthouse is 50 meters tall. So I can draw my 50 meters here. And the angle of depression is 42.5 degrees. And they're asking us to find how far. So that would be this right here. So picture this as C, A, B. And then this is little a, little b, C. So if they are asking us to find B, because they're saying how far, this is what we're trying to find. This means you have to find little b. Again, I only have opposite and adjacent from A, so that means I have to find tangent of A, which is opposite over adjacent. And my opposite is 50 meters, right? And my x is the little b. But then how do I find the tangent of A? Well, what I do, or how do I find B? The tangent of A is 42.5. And we have x here. What's going to happen is these two can switch to solve for x or b here. So it'd be 50 over the tangent of 42.5. But we're not going to do to the minus 1. We're just going to do 50 divided by the tangent of 42.5. And what we get is 54.6 degrees. So this is how we solve for depression. So this is the video on section 7.1, solving for angle depression, angle of elevation, and solving for angles and sides on a right triangle.